Hi, everyone, and welcome to the MLOps podcast. I'm Dean, your host, and today I have with me Liron Itzhaki, Allerhand. Um, Liron, thank you so much for taking the time. If you want, care to introduce yourself?
Yes, thank you for having me. Hi, I'm Liron Itzhaki Allerhand. I have a PhD in AI, ex-Microsoft, built and led the AI in two companies, and I'm now doing freelancing. I think that's about covers it.
Perfect. So the reason this episode came to be is I was working on a project with LLMs, trying to show how you can get LLMs from scratch all the way to production. And I wanted to talk to smart people that have already done that a couple of times at least that I could learn from. And Diron and I had this conversation about the various stages that LLM projects that actually end up in production take. And so I thought it was interesting, and I wanted you, the audience, to enjoy it as well. So, with that, Leon, what does production in LLM world even look like from your experience?
Well, production in an LLM world is the extension of AI in production or models, deep learning models in production. So you have all the software issues. You need to be able to scale. You need to be able to run this in a reasonable time, reasonable compute costs. Plus, you have all the data issues and inconsistency because models they're still software, but they're not perfectly consistent.
Fair enough. So, let's say tomorrow I'm starting a new project, an
Mhm.
LLM project. What are the concrete steps that I need to take in order to develop and then deploy that application to production?
Well, develop and deploy are two separate things. So for developing, I would say the biggest thing is the biggest two things are have clear, concise requirements and have good relevant data.
Mm-hmm.
And in terms of productizing it, LLM projects are usually productized with API requests to some provider like Anthropic or OpenAI,
Mm-hmm.
and you want to make it very well logged. So you want to record what you're sending out, which data you used, what answers you got. You want to make it as checkable as possible.
Okay. I think that what I was sort of seeing is that, as you say, like the first thing is you need to define the requirements. Then you need
Mhm.
to make sure you have data. And by the way, we'll dive into each of these steps and get your thoughts on each one. But basically, so define requirements, build the data set. There is sort of a step of like, this is the one that everyone talks about, like prompt engineering, maybe model selection, the Anthropic versus OpenAI, maybe open source in some cases, and then evaluation and deployment, right? So let's try to cover each one, starting with the first one. So you said like clear requirements, that's obviously
Mhm.
important, but if you can share maybe two pitfalls that you've seen in your experience that people tend to fall into when they're trying to define their LLM problems.
Sure. So I'll say clear and concise requirements, right? It's very easy to get an infinite list of requirements, and this has many issues. I'm sure we'll talk about some of them. But you want to also limit the requirements, even in terms of prompt length and generation time. That's very clear to everyone. Include an infinite amount of requirements. It will take a long time, many tokens, and also it won't really keep track of all of them. Um, Two pitfalls I've seen are basically around measuring it.
Mhm.
So it's sometimes companies think it's easy to tell if something works, and it's not always that easy.
Mhm.
And they have to really um, try to measure something. That's the best case scenario. If there's something you can actually measure, that's the best. But if not, you want to have some examples of what's a good answer, what's not a good answer, what are the different scenario, what are the different cases you want to handle.
Mhm.
That's very helpful to get a good result.
Okay. The the thing that you mentioned, like the the short sort of requirements. I think that one of the blogs that I read was using the comparison to like a long code files. So if you have a lot of requirements, that's going to end up being like a very long prompt. And in software development, when you have a very long code file, that usually is a sign that you need to break it up into smaller modules. I don't know if
Mhm.
this is sort of your conclusion as well, but to me, it was interesting to think about this in the sense of if you have a lot of requirements, that probably means that you need to break it up into different like sub applications, maybe. Now maybe everyone wants to call them agents, so let's call them agents. But
Okay.
try to sort of solve smaller sub problems and then later patch them together, as opposed to having one model with one prompt solve everything in one go.
Well, that's definitely something you want to do in general with current AI, current LLMs.
Mhm.
That's generally a good idea, but you shouldn't try to do too many things with one prompt. First, because it doesn't work, right?
Mhm.
It cannot keep track of too many requirements. So if you try putting 20 requirements, I'm exaggerating even 10 sometimes, it cannot really keep track of all of them in a good way.
Mhm.
So you will get the issue where why is it ignoring my requirement? Well, it has too many requirements, and it's not that different from a person in that regard, right? I was teaching a course in electrical engineering in Ben Gurion, and I was teaching them how to create some sort of a plot. It's called root locus,
Mhm.
and it has 6 rules for building it. And electrical engineering are brilliant students, but keeping track of 6 rules was too much for them. If they couldn't find the right way to move forward with the second or third rule, they started inventing rules that don't exist. And they come up to me and they tell me, hey, look, I tried to make it with those rules and it didn't work. So I kind of figured there's another rule that I have to follow, which is this. And I want to know if my rule is correct. We've been teaching that class since the 70s. That hasn't changed. It's not going to change now. Right?
Interesting.
And we carefully go through the rules, and then, like, it's the fourth or fifth rule that they have to follow. They just didn't have the patience to do that. And AI is starting to encounter the same limits as human intelligence. So it's losing track of all the requirements. It may not lose track in 4 or 5 requirements, but it will lose track if you have too many.
Mhm.
And also, it will take a very long time. The compute is quadratic in input lengths, in input tokens.
Yeah.
So you will spend a lot of time creating the generated text, and it's it may make your application,
Slower.
and taking so long to generate the text may make your application useless to the user,
Mhm.
right? So one fintech company I spoke with, they said, look, we have a great chatbot. It gives good answers. I just take so long that the user doesn't wait for the answer. There, by the time it gets there, it's gone. So
Yes.
that can work well for backend applications, but if something that's user facing, this is a very important thing to note.
Yeah, this is something that as technical people we sometimes tend to forget that real
Mhm.
humans are going to be using these applications, and there are external constraints that aren't related to how good the model is. Like if it's too slow, then no one will use the product.
Yeah,
I guess. Yeah. Sorry.
it's like UI for engineers where you have all the parameters in the configuration and you put them all as knobs, and an engineer looks at it and go, great, I'll tune everything until it works. And any normal human looks at it and goes, I have no idea what to do.
Yes. The Like I remember oscilloscopes from school, and not like you just press one button, everything else is like unknown. So okay, so we have our problem defined, and then we get to the point of like building our data set or data sets. So how do
Mhm.
you prepare data in LLM projects? And if you can cover both RAG, maybe fine tuning and evaluation data sets.
Right. Let's address that first. So I haven't really done fine tuning for any real project. Fine tuning is heavy, very heavy in terms of serving it,
Mm-hmm.
because you have to keep your own model. It has to be competitive with the big models you can get through an API, and you have to serve it yourself. That's not right for most organizations. So I would say, as a general rule, stay with served models unless you have a really good reason not to.
Fair enough.
So now if you're buying the models through an API and you have your evaluation data, those are both fair. So the RAG, by the way, in agentic workflows, you want to be thinking about more than just the RAG, the retrieval of relevant information. You
Mm-hmm.
also want to be thinking about relevant examples, because you don't always have to include all the examples and relevant guidelines. You can make that adaptive as well.
Mm.
So you can think about all of those, but let's talk about the data. So you always start, same way as a machine learning project, you start with an EDA, exploratory data analysis. So you start by looking at your data and kind of checking how it behaves. Is that what you want it to be? What's missing? How do you see the distributions? What are the rare cases? And so forth. So one thing to look for, in LLM projects is requirements mismatch with how things work. For example, um, you'll be making an AI sales representative, and the representative is given instructions to answer in a certain way, but then the examples you have to give it and what you see the behavior of the human representatives in the data doesn't match the
Mm.
requirements. One example where um, this actually was discussed in Parliament is with autonomous vehicles. It's
Mm.
another case of AI, right?
Sure.
But for autonomous vehicles, for example, they really don't have examples of humans stopping in a stop sign. Humans do what we call a rolling stop, where
Mm-hmm.
you don't actually stop.
Yeah.
And then the legislator referred to that and said they expect autonomous vehicles to actually stop, not just do a rolling stop. And that's in the UK, if I recall correctly. My
Interesting.
recall is not perfect either, not just the models.
But perfect precision. No.
Well, thank you. So you want to look at mismatch with requirements. So if um, all of your examples, you see the representatives being not that professional, or not that careful with their answers, and then you're told the model has to be perfectly careful, then you have to say, look, where do I get the examples for that? Right. So that's something to note for. So that's something to look at. You want to look at data issues like anonymization. Anonymization can be very useful, but it can also create a problem. Like you have anonymous in the middle of the data, that could lead to some weird answers from the LLM.
Mm-hmm.
You want to look for examples you can put in your golden set. So what the data set that you use to evaluate the performance for the specific case. Um, you want to look for cases where you have issues of exact matching. So if you're, for example, if the user is asking about, I don't know, a certain laptop, right? If they have a specific model, they need an answer that's relevant for this model,
Mm-hmm.
or for example, the link to the page that's relevant for this model. It's not semantic similarity.
Sure.
It's the exact match.
Yeah.
So you want to look for cases where retrieval with embeddings is
It's
not
not
the right way to go.
interesting.
And lastly, I'd say think about general risks. What kind of data could leak here? If you're running things with your result, for example, if you're running SQL queries, then you want to be careful with running SQL queries. What kind of queries are available in the data? So you want to be able to limit it as much as possible from the databases side. Like, don't allow delete operations, right? Very obvious.
Sure.
But then you say, okay, I know I will not allow delete operations. Great. What kind of update are you doing? Are you doing general updates? Can you limit that in some way? It seems like the app is agreeing with me.
Yeah.
So you want to think about those things. So that's kind of like a very rough checklist off the top of my head of what you can think about when you're doing EDA for an LLM project. When you're handling data, you want to think about chunking, of course.
Mm-hmm.
So that's something that's new with LLM or foundational AI projects when you're doing RAG. So far, we had the data prepared in advance. Now, another aspect is not just the data, but how do you chunk it? What are the pieces of context that you give?
Yeah.
So most types of data would have a natural kind of chunking, right? So text has sentences and paragraphs and sections, and code has lines and functions and classes. So most types of data would have some native division within it that you can
Mm-hmm.
use for chunking. Another thing to be careful when you're looking at that is sometimes you get error due to the format. So for example, in PDF format, you can get an error where a paragraph can be associated to a different section when you parse it into a simple text file, but it's not how the PDF is presented to a human.
Yeah.
So you want to see if you can put some kind of safety measures around that. And if you're looking at natural chunking or rule-based chunking, that's easier. The alternative that's being sometimes is being used is something called semantic chunking. And
Okay.
semantic chunking is you use a model to kind of understand what kind of pieces go together. In Microsoft, we have a patent on something like that for the output, not for the input in that case, but we did a form of semantic chunking, and that was very useful for that app. But it's not really, from what I've seen, it's not really that useful for LLMs. And there's also a recent paper that explored that, and they said, look, it costs a lot of compute, and the improvement in the result is quite negligible.
Mm-hmm.
I think it's even entitled, "Is semantic chunking worth it?" And the TLDR is no. But you can try that for your use case if you need the chunks to be very specific. That's useful.
Mm-hmm.
One thing that I have found useful is including extra context. So the key insight here is this. When you're chunking, you have a key and you have a value. You're basically doing retrieval,
Sure.
right? So what you do, you take a chunk of text, you put it through an embedding model, you have a vector, you put that vector in a vector database, and then you use it to retrieve that chunk. But you don't have to keep the exact same chunk as the value that's being retrieved. You can create the vector key with one chunk, for example, one paragraph, and then when you retrieve, you can bring something slightly different. For example, the three paragraphs, one before, the paragraph used, and the one after. So you
Sure.
include more context
Mm-hmm.
and you kind of give it a bigger scope in case something was mixed, or in case you cut too much, you cut into too small chunks. You cut the chunks too tightly, because cutting chunks tightly is useful.
Mm-hmm.
But then if you can make sure the LLM doesn't encounter errors because of that, that's better.
Yeah.
That would help the design, particularly if the information would go together, right? If you need the context from before this paragraph and you need to understand the implications on the next piece of text, then it's useful, not in every case. Another thing I will look for is what are the dependencies in the data,
Mm-hmm.
and do I have access to them, and how do I choose the right ones? So let's get back to the sales representative example. If you're building a sales representative, what will a sales representative do to close a sale? They will say, oh, there's a sale on that,
Mm-hmm.
right? Get a discount or limited time, something like that. Well, if you just give those as examples, the LLM will hallucinate a sale.
which you don't
That's
have.
not what you want.
Yeah.
You want to give it as a context where there are any sales that are relevant. What sales is it allowed to offer?
Hmm.
If you don't give it sales, it will hallucinate something because those are the examples you're giving it, or it will never offer a sale and will not be effective.
Sure.
So you want to be able to offer that, but you need a context because it cannot decide on sales. Of course, if you're allowing your LLM to decide on sales, that's great. Just be careful. It may give 120% discount.
Sure.
And in that case, please call me. I would like to buy.
I think Chevrolet had a problem with that. They had like a sales agent who was saying that there were like ridiculous sales on cars, and they ended up shutting it down. So yeah, don't do that.
Less than 100% is not that ridiculous. I've seen worse.
Fair enough.
And what you also want to think about in terms of the retrieval, so you want to think about what's relevant in your case of the data. Is it just the relevance of the data itself, of the text chunk? Do you need to consider diversity, having different pieces of text from different places that are all relevant in different ways? And do you need freshness? So freshness is very easy to understand, right? If I'll ask you who's the president of the United States, um, when the model trained, the answer may be different than it is when the user is asking it. And you don't want to rely on the model for that. You want to make sure you're giving it a fresh context.
That's all super valuable. I think two takeaways from what you just said that I also experienced building the project now is one, it can't be said enough times. You have to actually look at the data. Every time you do it, you like, at least for me, every time I actually looked at what's going in and out of the model, uh, and what is the structure of the data set that I'm building,
Mhm.
how am I connecting the reference answer to the question and things like that. I learned things either about how I need to change my project. So
Mhm.
whether it's like a prompt or actually introducing logic to cover for like a problem in my application. To give one concrete example, I used a RAG application, so there was context being provided, but I noticed that in some questions the context, like the answer, doesn't appear anywhere in the documents, and so the context retrieved is not relevant. But because the model gets the context, it tries to base an answer off of it, which causes it to hallucinate. So adding the ability of the model to disregard the context
Mhm.
is valuable, and you don't understand that if you don't actually look at what the data is compared to the questions and understand those. And the other thing relating to what you're saying is on the chunking part, you gave me an idea which I'm going to try in the project afterwards. But I was doing chunking and I was doing overlap, so that, as you say, like if I'm looking at a specific, if I'm taking a specific chunk, it also has some of the components of the chunk that came before it, so there's some overlap, um, and that makes sense. The problem is that it was hard for a bunch of different reasons to make the overlap component, let's say, logically consistent, so a full sentence and not like a number of characters which might be cut in the middle. But
Mhm.
it might be solved if I was encoding only the chunk and then indexing with the overlap. So I might try that and see if I get better context retrieval, like more relevancy. So those are all really great.
Great.
Yeah. And so we have our data ready.
Mhm.
I guess one question that I still have about the RAG part. So this came up in a lot of conversations with practitioners. So I'm sure a lot of people would love to get
Mhm.
your thoughts on this. But how do you deal with multimodal RAG? So let's say I have a model and the context needs to get images and text both. And let's say they're all, coming from the same domain or maybe same documents. But how do I deal with that, basically?
Well, I haven't really done that in practice, but I would first try to understand, like, why do I need both of them, and can this be reduced? If you're giving me an image of, I don't know, from a vacation you had, and you want to ask where was I, where did I take this picture, that's kind of different from giving me an image of a table and asking me about the numbers or something which may not even be in the numbers,
Hmm.
right? So understand how is that made. And if you can structure the images beforehand, that's better. So if you can just, for example, do OCR or object detection and then index the objects or use the text that's in the image, that's probably a better way to go.
Yeah. Okay, fair enough. So,
And
yeah,
one
sorry.
one thing which seems relevant here is there is a work called struct RAG, where their main idea is this. Well, I have different types of data, even if it's only text, particularly if it's multimodal, right? So you can have a paragraph, you can have a table, you can have an algorithm or pseudocode, all
Sure.
those things. And then before you retrieve, you use a classifier to tell you which type of modality do you want to retrieve from.
Hmm.
And
So,
then you do the actual retrieval. And that's very useful, not just on a level of retrieving from the right place, but also that makes the indexing easier, because then whenever you're looking for something, you're looking at a smaller database.
yeah, okay, that makes a lot of sense. That's also something to try. So, okay, so now that data is ready,
Mhm.
I think that there's a lot of ink spilt on prompt engineering, so I don't want to spend too much time on it. But if you can give like top two tips for doing prompt engineering well.
Well, you want to limit the amount of requirements and the overall size of your prompt. That would be number one. Number two would be trying to look for edge cases and exploit niceness. So I'm kind of pushing two tips into that one because you only gave me two. Um, so if you have, if you use an LLM, it's usually trained, the alignment part is training it to be nice.
Mhm.
And if you express like what you want the answer to be, it will try to please you. So you
Mhm.
can see if you can exploit that, because the user will have their own desires, what they want the answer to be, and they will not try to compensate for that. They will not try to make your app work well,
Mhm.
right? So you want to see if you can easily break it. Like, is this meaningless? And if the LLM sees that and goes, well, he obviously wants to get the answer that it's meaningless. It's an easy answer. You want to see if you can get it.
Mhm.
And if you do, maybe emphasize that more in the prompt.
Interesting. Okay. And so after we've gone through this like prompt engineering, we get to the model. And I know
Mhm.
you mentioned that you didn't see a lot of actual need for model fine tuning, but do you customize the models themselves in any way? If yes, how? And then how do you evaluate the newer versions of the model?
Um, well, the I don't change the actual models usually,
Okay,
or I've never actually changed the model for something that goes into production. What you're evaluating essentially is the prompts and the data retrieval, the RAG scheme, and the examples you gave it, and so forth. So examples are an important part of the prompt, of course.
sure.
And that's a prompt in the general sense, because you can give it a whole conversation and consider that a prompt.
Hmm.
So, so that's what essentially what you're evaluating. And if you can evaluate, you, and when you evaluate, you want to use a golden set ideally. If you can't use a golden set, you want to use, well, it's a very big question, right? But you want to have some proxy. So a general thing, and I mentioned that very early on, just what's a pitfall, and I said it it will be easy to see if that works, right? That's a pitfall.
Hmm.
So you want to have some sort of a concrete measure, as concrete as you can. So if you can't have something that you can actually measure and is a number, so you
Hmm.
want to have something you can kind of measure, like, you know, are users happy in a general sense, or we will look at the examples, but we will look for niceness and correctness.
Okay.
Okay. And then, like, if the tone is not perfect in some cases, that's not that big of a deal. And it's very helpful that this was brought up early on.
Sure.
You also have various metrics. The one I always have in mind is toxicity, right? How so that's correlated to niceness, but you can have consistency and brevity and so forth.
Hmm.
And there is a very well-known company, at least in the local ecosystem, called Deep Checks that will be very happy to give you some of those examples out of the box, some
Hmm.
of those metrics. Um, in terms of evaluation, and we had a table discussing this at Indie Devs. I don't know if there are still Indie Devs event happening, but if there are, you should come. Um, and we're discussing evaluation. One big thing that came up was if you can break the model into steps, then you can evaluate the steps separately. Of course, those
Hmm.
are fixed steps. If the model is generating its own steps, then it's harder to evaluate. But
Sure.
if you have concrete steps and you know what each of them should do, then you can evaluate each of them independently. And then if you're evaluating actual text as text, the ways to evaluate it are there are three ways. You can crispify them, you can embed them, and you can use an LLM as a judge. I'll explain all three.
Okay.
Or maybe I'll explain two and stop in the middle.
We'll see.
I'm kidding. So crispify means turn this into something you can measure, right? If you have a fixed set of answers, give check if it's within the fixed set of answers and is it the right one. So in that case, you can reduce it to a precision and recall problem.
Sure.
Right. So if you can, it's not always possible, but if you can make it a crisp answer, make it if
Make.
you can make it a crisp answer, make it a crisp answer. If you can't, then you can compare embeddings,
Hmm.
and you can maybe massage those embeddings a little bit, but basically with embedding, you can ask, is that the same thing? Is that semantically similar?
Hmm.
And if you're willing to pay with even more compute and you want to ask complex questions, you can use LLM as a judge, which basically means give the answer to an LLM and ask it how good of an answer is it. And maybe you have fixed context, you've hand curated the questions and the answers and like compare this answer to the golden set answer. You can use an LLM in various ways, but just essentially asking an LLM is a way to evaluate that automatically. Of course, human evaluation would be better.
Yeah, I think that LLM as a judge. So I created now an LLM as a judge runner for my project. I was actually surprised by how good it worked. Like
Mhm.
I asked it to return structured output consisting of a score 1 to 10 and a plain text explanation of why it gave that score, and it was
Mhm.
like spot on. I was using GPT 4o to evaluate both 4o mini and an open source model,
Okay.
just to see like what they compare. It was very nicely done and not a lot of work. Like basically you can set
Mhm.
up. I feel like LLM as a judge is being made out like sounds very sophisticated, but you can actually implement it in like 10 lines of Python, which is
Mhm.
very nice. So I'm curious though if you think that this works like at scale, or if this is a gimmick for now.
Well, like anything, this technology is not yet mature. It's a
Mhm.
good idea that will get better. The kind of analogy I have is communication networks when they started, when we were talking on cell phones in the early 2000s.
Mhm.
You had bad signal, you could barely hear, but it was better than going to a landline.
Yeah.
If people today don't know what a landline is, it's a phone that's connected to the wall. And if you're too far from your wall where you have your phone, you cannot talk to other people on the phone. That's called a landline.
Sure.
So you could talk on the landline, people would hear you well, but you want to talk wherever you are. So you would talk on a cell phone and it would be noisy and it would sometimes disconnect, but it worked. And you wanted to use that because it was much easier and better for the task you were trying to achieve. Same thing here. It's not perfect yet. It will get better. You will experience noise. You will experience cases where it's supposed to work but doesn't. But still better than the alternative in many cases, which because the alternative is a human, and those things are so problematic. And you brought up something else, which is like checking structure, like a JSON structure, and that's a type of making things. That's a type of making things crispy,
Mm-hmm.
crispification. And that's actually a big part of the current renaissance of reasoning models and using RL for training LLMs, because you're using, for example, give me a structure and you're checking the structure. Take the output, put it in a JSON parser or an HTML parser and make sure it works, or run the code, make sure the code compiles, make sure it runs without error.
Yes. Yeah.
Right? So those are also examples of crispification.
Yeah, I think those are really good to illustrate what we're talking about with this, and I think that also with the LLM as a judge, you can try it out. You can see that it's very that it has a lot of potential. We
Mhm.
need to make it work at scale. Like a lot of the problems is making it, as you say, consistent, which is why like my tip again now from practice is make sure you do like exception handling if you're doing LLM as a judge, and making sure that the flow works in a way that makes sense, even if the judge fails. So it might be not that your model is failing, but that the model that you're using to evaluate your model is failing, and you should be able to handle that. And the other personal conclusion, which is really the same as your original point about golden sets, I think that there's still no good replacement for investing time. And it's not like most of us don't like building data sets manually, but I think there's still no replacement for handcrafting a really nice golden set. I think a
Mhm.
good rule of thumb is like probably you're aiming for low hundreds of samples in an ideal setup, and making sure that you're also covering the different edge cases. So if you're trying to test for something specific, make sure you have, I don't know, 20 examples of that thing, so that your model can actually be tested against it. Um,
Yes.
yeah.
Covering the different cases is very important. It's good that you brought that up. I would also say covering the different types of cases, edge or not, by the way, is a good practice if you cannot cover all edge cases with real examples. So cover the ones you can and see if you can put synthetic examples for others. But also, in the general sense, models change, performance sometimes fluctuates, and you want to think about your system in a way that one error, one place where it performs badly, will not break the whole system or will not break your relationship with the customer.
Yeah.
Because at scale, these things will happen. Everything that's relying on AI, deep learning, machine learning, you will always get errors. And we've all had cases where someone from business side or the product is very scared and is coming to us, can we make the models consistent? Can you tell me what went wrong in that case? Right. So that's something to be aligned on in general, and we're going into an AI world. So
Mhm.
I expect that to be more common type of thinking. It's already a lot more common than it used to be.
Sure, I agree. And this actually relates to my the next question I wanted to ask, which is usually when I talk to people building
Mhm.
LM applications, when the topic goes to hallucinations, they have a
Mhm.
tendency to smile and say like, "Yeah, that's hard." So, have you seen any good approaches to reducing hallucinations and making the answers more consistent, as that figurative product manager was saying?
Yes, you actually brought it up earlier as well. So the best formulation I heard is from David Columbus, and he told me um, LLM is not your whole software. In software, you have databases and you have functions. The LLM is a function, it's not a database. And
Mhm.
what that means is that we shouldn't expect the LLM to have data stored within itself. We want to give it the data and call it kind of the way we call a software function.
Mm-hmm.
Those are your inputs. Give me the outputs. Make, have few inputs like you already mentioned, right? Not just, it's related to your example about using big files,
Mm-hmm.
big function. Well, also not using too many inputs into a single function
Mm.
is a software pattern. That if you're using a lot of inputs, things will get lost in the middle in the LLM. You want to give it concise inputs and then get concise outputs. So you gave the example when you were giving it irrelevant inputs, and then it hallucinated an answer based on those. That will
Mm-hmm.
still happen. So you want to make sure you're giving it the context it needs and just the context it needs, and you can do re-ranking and filtering steps to make sure you're not giving it things that will do more harm than good.
Fair enough. And in a similar vein, one of the things that I think is scary to people with respect to hallucinations and like the inconsistencies or uncertainty in LLMs is the idea that if I'm an enterprise and I'm building my own LLM application, I might expose that LLM to sensitive data, whether it's sensitive
Yes.
because like company secrets or user identifiable information, and that will leak. So, how do you think about dealing with like data leakage? Are there any solutions? How do you? Yeah,
Yes.
what have you seen?
I'll start by pointing out the problem is actually worse than you think at first,
Oh no,
because not only can you accidentally leak data like, here is Dean's salary. Oh shit, he's really not making enough money. Um,
maybe.
can we say oh shit on a podcast?
In this one, definitely.
Okay. So, but you were not supposed to tell the person that salary. You're actually also at risk of the LLM piecing things together, kind of like, doing research work, because you're giving it a bunch of chunks and it can put all of them together and reach a conclusion, and you didn't even mean for that conclusion to be out there. It used to be very hard for a person to have to do a lot of research, maybe
Mm-hmm.
have to hire a team of people to go through the data to reach that conclusion. And now an LLM just pieced it together for someone that it was not
Interesting.
meant to, it was not meant to be distributed, or it was meant to be hard to reach, at
Yeah.
least. So yeah, that's a risk. And the risk is in enterprise applications, it starts from the data layer, because ideally you would have kind of a shadow role whenever someone asks an LLM a question. Whenever someone tries to find out the answer for themselves, you have data management, right? You have identity management.
Mm.
The organization knows who the person is. They try to access data, and if it's within their permissions, they can access it. And when that person asks an LLM, it's not managed by the person that's asking the LLM,
Sure.
right? So there's no like shadow role of an LLM answering Liron's question.
Mm-hmm.
That's not a thing that exists yet. It probably will. So, um, so that makes it harder to prevent. So I would say, if you borrow a term from finance, I'd say do a KYC, know your customer or know your agent.
Mm-hmm.
So what kind of data does this agent need access to, and limit it?
Sure.
And you can also limit different parts of the workflow. If you reach this part of the workflow, then you don't need access to that data, so don't give it. But just let's start from the basic. Know exactly what you should do and what kind of data you need to give it access, and then limit it to this data. So that's the basic thing. The harder problem is not that easy to solve. There's an Israeli company called Gnostic that's trying to do that. They
Mm-hmm.
actually have a very nice idea, but I don't think we want to get into what they specifically are doing.
Mm-hmm.
So this is a hard problem, because if you're giving it access to a whole organization's data, it can answer it can give anyone an answer based on the data. Ideally, you want to limit it in some way, and think about it for your own project, I'd say, depending on your needs and how much time you have to develop it. Maybe you need to develop, I don't know, a shadow identity management system. That would definitely be the most extreme case.
Well, I don't know if they're out of stealth, but I know at least one startup that's working on something in those areas. Um, the one thing that I have heard relating to this is a lot of times defining what is sensitive data for an organization is more straightforward than people think, and that means that you can get away with a simple either a transformer or that's trained to detect certain keywords and things like that in sentences and say like, oh, this is sensitive, maybe we
Mhm.
need to not let this reach the user. And in this case, you're sort of implementing this not on the development side to prevent leakage, but on
Mhm.
the inference or deployment side to prevent the leakage from getting to the actual end user.
Sure. So
um,
you can leverage any type of DLP syncing. DLP is data leakage prevention. It's
mhm,
a suite of security products. And actually, that's a very interesting idea. So you're generating an output,
mhm.
just submit it to your DLP system.
Yeah,
And if it raises an alert, well, reconsider that,
yeah, that's
right?
nice.
So try it with the data, for example, prevent access to pieces of the data that would trigger the DLP. Very nice idea, actually. I like it a lot.
Awesome, thank you. So let's end with three fastball questions, which I like to ask
Okay.
all the guests in this podcast.
Mhm.
One is, what are you most excited about in the fields of machine learning and AI?
In context learning.
Okay, what does that mean for those that don't know?
In context learning is that we're able to take a model that's already been trained, we're not training it anymore, and while it's working, we're teaching it new things that it's then using in its output. So few shot examples are an example of
Mm,
in context learning.
nice. But this, by the way, just out of curiosity, would uh, models that update the weights in at inference time, would that be considered in context learning, or is that like just test time, whatever adaptation or something like that?
Well, that depends how are they using those weights. If they're just continuously training their weights, I would say they're in inference, but they're still in training.
Hmm.
If they are using the weight changes to answer specific questions, like what's happening now and not just long-term improvement, then
Sure.
that I would say that's in context learning.
Okay, fair enough. So next question is something. Tell me something that you think that is true,
Mhm.
but few people would agree with you on in the field of machine learning and AI.
Well, I'll start with the first layer, which is more agreeable, which is we're experiencing a separation between the foundational model layer and the vertical application layer.
Hmm.
Companies used to serve customers directly and they would develop their own models, and now we're seeing a separation. You have the foundational models like GPT, Claude, um,
Sure.
anything you can think of, Runway ML, for example, for video, or
Hmm.
Hour One. And then you have the vertical companies that are actually using the models. They're not developing them, they're just using them to serve a customer. And they're doing less and less of the deep AI work or deep scientific computing to serve their customers. That
Hmm.
I think most people will agree with.
Sure.
And I think what we'll see is more and more shift towards using foundational models in the API, since we're seeing the shift to using APIs instead of managing your own servers for the models. Then this activity will move to the DAL, the data access layer.
Hmm.
So when you're running requests that you would have previously run to the backend, the same layer would also call the model API.
Hmm.
And then there will be more need for modelers, for AI people that can work within the DAL, which is usually developed in JavaScript.
Interesting.
So you will see a demand for AI people working in JavaScript.
Interesting. I have not heard that take before. So if you're listening and you're not sure what your future prospects are, maybe you should learn about JavaScript plus data. Thanks for that. Last question is recommendations for the audience. Does not have to be related to data science and machine learning, whatever it is.
Okay. So let's go from the more data science to the less data science. First, prefer RAG to fine tuning whenever possible, because you don't want to run your own models in production. That's a hassle.
Mm-hmm.
If you cannot measure something directly, try to measure it indirectly. We discussed that in depth for different model performance aspects.
Mm-hmm.
And the last one, I would say, meditate. That's good for you.
Any specific meditation you recommend?
Focusing on your breath. So all types of meditations are good. The very basic approach is sit, pay attention to your breathing, and if a thought comes up, let it pass, then get back to your breathing. If you lost yourself in thought, that's okay. Let it go, get back to your breathing. That's not only is that not bad, actually the getting back to the breathing is the main thing you're doing.
Mm-hmm.
So if I meditate for too long without a thought coming up, I'm not actually meditating. I need to be able to refocus to get a benefit.
Fair enough. That's a great recommendation. I agree from my experience too. And with that, Liron, thank you so much for taking the time and speaking with me today. It was a
Thank
pleasure.
you for having me.
And thank you to the audience. I hope this was. I hope you learned as much as I did. And I'll see you here next time. Bye.
Thank you so much. Great questions.
Thank you. Bye-bye. Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.